Hey, it's John McBride at RMUS. We have a really good webinar to present to you today, focusing a little bit more on our LiDAR. So there's definitely a lot of people that have LiDAR questions, don't know much about the sensors. They do know a lot about the sensors. There's lots of questions on exactly how LiDAR works, the data we get, how we then move it from collected data to processing it, then actually creating deliverables from it. So with as many different products out there as can be very confusing, we definitely want to showcase a new kid on the block, if you want to call it, in the UAV industry, GreenValley International. We're going to be discussing with them a bit about their products and how they're servicing people. So they're not really new, but they're new as far as I know, and kind of understanding how they fit into the current UAV industry of today. With me, I have Kevin Totterall from RMUS Canada, who definitely has been the spearhead in this relationship and working with GreenValley. And we have Fraser Hahn, one of my expert technicians up there in Canada as well, who will be kind of showing us a little bit of the hardware. So from here, I definitely, a little housekeeping things. If you're watching the broadcast, please feel free to put any questions in the chat window. I'll try to answer those as soon as possible. Additionally, if we need to then ask the guests or anything, then I'll moderate those the best we can. So any questions that you might have, go ahead and put it in the chat window of the Vimeo stream here, and I'll try to get to those as soon as we can. This is about a 45-minute presentation, so and we'll leave a little bit of more time in there for questions, but hopefully everything goes well and we don't have any problems. So Kevin, I'll give it to you.
Thank you, John, and thanks for the introduction. Happy 2021 from Canada. We in RMUS Canada and in the RMUS family, we're excited and excitable people in general, but certainly in 2021, despite everything going on, we're even more excited about this marketplace. We are seeing new things coming up all over the place. We're seeing new domestically made UAVs. We're seeing new sensors. We're seeing new applications for sensors. We're seeing new demand for these sensors, particularly LiDARs. It's really, really exciting, and there's never been better choices or more choices. So it's great for new opportunities, and this is what we're going to talk about today. So I'm really happy to announce our official partnership with GreenValley International. We've been watching them for a long time now, and we've been interested in working with them, and here we are. And so really, when we look at our history with LiDAR, we were the pioneers really in North America for UAV-based SLAM LiDAR for some of those confined spaces and underground, which is a very, very specific niche. But the reality of this is that the bulk of the market, particularly the bulk of where the market is growing now, is survey grade LiDAR. So can we replace photogrammetry? Can we do things differently or better than with photogrammetry? Are we able to find new use cases that maybe we couldn't do? And certainly part of that has been the renaissance in ease of use, improvements in accuracy, and certainly cost. And so we are excited about this particular partnership because we'll be able to bring that survey grade mapping quality LiDAR to the marketplace. So that's what we're going to talk about today. So what I'd like to do now is just quickly introduce our guests from GreenValley. We have Liam Meyer is here. He'll be talking to us later. That's Liam. And we also have Leo Liu, who's Director of Sales and Marketing. And so, Leo, I'm going to throw it over to you for the first question. For people that maybe don't know, what's GreenValley International about? Give us a quick background. Tell us about where you came from and where you're going.
Thank you, Kevin. Thank you. Thank you, the entire RMUS team. It's a great pleasure to be here, and we are very excited about this new partnership with RMUS. This is fantastic. Now, I'm going to just give a very quick and brief introduction about GreenValley International. GreenValley International is just a little correction, not really a new kid on the block. We are one of the first movers for this industry. That said, ultimately, what we want to do is provide the best options possible to all the customers out there who are already either using LiDAR industry or LiDAR technology or wanting to get into this service sector. All right. So again, ultimately, we want to provide options. As you can see on this slide, we have a good number of options for, at every tier, from entry level to high end.
And we don't, Leo. We don't have your slide. Real quick, share your. If you want to share your screen, do that real fast.
Sorry about that. Technology. Being a technologist, I need to catch up more on this. Okay, here's a slide. We want to provide ultimately the best options possible to all the users and customers out there who want to get into the LiDAR service industry. And we have a series of models in our light air UAV LiDAR portfolio that are available for your choice. And exactly which model is the best for you, it's really very much determined by your own business plan. And there's a lot of factors to be considered. But just one thing I want to point out is all these models we provide in the light air portfolio are capable of delivering survey-grade results in typical operating environment, which will be discussed later on by Fraser and Liam. Now, about GreenValley a little bit more. GreenValley is one of the leading providers of LiDAR mapping solutions. We have a full portfolio of aerial, UAV, mobile, terrestrial, hardware, and software. And more importantly, we actually have a very big service branch. And that gives us quite an edge, because being able to, having this experience in providing actual service, conducting service projects, that gives us a lot of a good experience from the field. That helps us to actually continue to improve our products, both hardware and software. So that's, I would say, is something that's quite important to consider. GreenValley started all the way back in the early 2000s when the founder of the company, Dr. Michael Gore, in this picture, you can see him in both pictures, was still in the University of California, Berkeley, during his PhD program. And the original idea really was to solve his own problem of not having a good LiDAR data processing software to address his research needs. And that's where, how the company actually started. And long story short, we often just officially date GreenValley International from 2012. That's when the company received the seed round of funding. So today, GreenValley International is still funded by venture capital. And over the last 8+ years, we have gone through quite a journey of product development. And there's a lot of new technologies being accumulated in our arsenal, and products, again, from software to hardware to service solutions. So we have I would say, just about anything you can think of. But today, we just want to focus on the UAV LiDAR sector. And to date, GreenValley has already developed a partner network over 60+ countries. And we have a customer base from just about all the major countries you can think of. And for us, North America is obviously one of our most important region. This is where we started. We still have this office right here in Berkeley. We are literally at the entrance to UC Berkeley. And if any of you ever get a chance to visit Berkeley area, let us know. And we are here. And we have offices across different regions. And we are very excited to continue to expand our partner network as well as our customer base. And by joining hands with RMUS team, we are super excited. Just one more very, very, very capable partner entering this landscape. And with working together with RMUS, we hope to be able to bring more and better options to all view in Canada and beyond with the all the new products we are continuing to developing. And with that, I think I will conclude my introduction of the company, and I'll hand it over to Kevin.
Thank you very much, Leo. Yeah, it was great to have a little bit of background on it, and I echo everything you say. And one of the things that we really like about the partnership is one of the things you find in the LiDAR space with, particularly with UAV LiDAR, you have people that are selling it, and there's obviously going to be challenges in the field for people that are new to using it. So it's really important that that we have a partner that works with us to make sure that our team is up to speed and top notch, as we always are, but that there's also service and support from people who know what they're doing at the manufacturer in real time. So we really appreciate that. So I'm going to throw it over now. I'm going to ask Liam a couple of questions just to walk us through some of the challenges, like how do we know how to pick a LiDAR system? How do we get accuracy? Things like that. And then Fraser will actually show you the system and how easy it is. So Liam, first question, walk us through the accuracy basics. What does accuracy mean when we're talking about survey versus mapping, relative versus absolute, just high level?
Excellent. Yeah, Kevin, thanks for having us here today. It's really exciting to be part of this webinar and kick off the partnership. I do handle a lot of the technical questions here at GreenValley International from end customers and partners, and accuracy is right up there on the top of discussion points that probably we have conversations about here on a daily basis. And there's different levels of accuracy across the spectrum of available UAV LiDAR systems. Now, where we are fitting in is this survey level of accuracy, right? So what this is generally defined as within the industry is being able to hit 5 centimeters root mean square error vertical accuracy, right? So that's going to be if you take a survey control point, something that has a higher level of accuracy, let's say less than a centimeter or a couple centimeters, and actually fit to the nearest point measurement to figure out what the residual distance is between your LiDAR point and that known point of a higher level accuracy, your survey data. You're going to do that across your project area. And then when you calculate the statistics on that, specifically one called root mean square error, you should see it be about 5 centimeters. So we can contrast this against maybe something like mapping level accuracy, which is 10, 20, 50 centimeters is what your root mean square error value would be. And this would be maybe observed in something that has less capable IMU or a sensor itself that has lower levels of accuracy and precision. What I mean sensor in this case would be the laser scanner or the LiDAR sensor. So what I'm discussing here is called absolute error. And this is because we're to figure out what that residual is, or that amount of uncertainty in the measurement or distance from the known point. The known point comes from a survey GPS point that's been maybe PPK processed, RTK processed, typically collected from a professional surveying system. Whereas relative accuracy is going to be also important to your data. And this is basically within the data set itself. So let's take an example of you have a 3D point cloud of a building. I know this building is a roof line of exactly 10 meters. Well, since the absolute accuracy of my system is about 5 centimeters, meaning it can be plus minus from the known 5, I would expect the largest amount of observable error in the relative accuracy to be maybe plus minus 5 or 10. So what that means is when I took a measurement in the point cloud from one end of the building to the next, I would expect it to be anywhere from 9.95 meters to 10.05 meters, right? So the plus minus 5 meters, 5 centimeters, excuse me. So that's kind of a rough way in some ways of describing two types of accuracy, absolute and relative, as well as talking about the different levels of accuracy as far as the industry describes them being either survey or mapping grade levels of accuracy.
Kevin, we do not have your audio. I'm going to come to you, John.
Okay. It seems we have an audio issue with Kevin for the moment.
Oh, sorry,
try to
guys.
figure out
No,
what's
no,
hey, there
I'm
we
on.
go. Back to Kevin. And I did want to
not an
interject
audio
real quick.
issue. It's a dummy muting issue. Anyways, thanks, Liam. I'm going to come right back to you, but you mentioned a couple of things. It's important to understand the needs in terms of relative and absolute accuracy. But the other part of this now is you mentioned IMU, laser scanner, ground coordinates, all that kind of stuff. So there's a lot of moving pieces that bring together the accuracy in any of these systems. So can you kind of walk us through, I'm assuming the accuracy is system-wide, like what are the pieces that bring us that level of absolute accuracy in the final outcomes?
Yeah, Kevin, great question. And you hit a really important point when it comes to talking about accuracy, right? So a UAV LiDAR system is actually an integrated system made up of many different components. And they each have some amount of error that they introduce to the overall system accuracy. So the core components of any UAV LiDAR system that will introduce accuracy into the overall, error into the overall system accuracy are going to be the laser scanner itself. Here we have in the LiDAR V70, we use the Livox Avia sensor. And then you're actually going to have error introduced from the POS system, POS system. And what this is actually it's a GNSS or GPS data collection device, as well as an IMU. And these two are integrated together through a span technology. And essentially, this is going to introduce error into the overall system accuracy. So error is additive. So the actual amount of error introduced by each one of these components is less than the overall system accuracy. But when we say 5 centimeters of accuracy, we are talking about the integrated system. So this is important when you're looking to purchase a system, is that you don't just look at the accuracy of the individual components, but you really zero in and focus in on those technical specifications that state the system level accuracy.
Perfect. So if we're understanding then the overall components, we've got some kind, we've got the scanner, we've got whatever we're going to be flying it on, we've got the integration with the platform, we have some pre-processing, we have a base station, and we have post-processing, and how it flows through that is what's actually contributing to the factors. Because I know we get a lot of people who are really good with Google, and they say, hey, I can buy a Velodyne puck sensor for $8,000. Why can't I just put that on an M300 or an M600? So obviously there's a lot more to it than that. So Liam, based on that, and we'll show everybody the system, Fraser will take it through, but Liam, last question before we do that. So if people are a little bit newer to the systems as opposed to what the results are, what should they be looking for? What are the questions they should be asking about particular features, about particular ways of evaluating if it's right for them? What are some tips that you would have for them?
So my biggest tip really would be to really have a clear understanding of what your objective is, meaning what is your target end customer if you're a service provider look like? What is the contract you would like to put in a proposal for and win? And oftentimes projects like an RFP is put out, and they'll have certain requirements that must be met from the point cloud data and any deliverables that will be generated from that. And usually that's going to drive you towards the level of accuracy that you need in your system. So for many projects, mapping level accuracy is maybe okay, but for others, you really need the survey. So once you get kind of past that decision node, then you can start to look at the survey level systems. So within our catalog, we have our Regal integrations, which can get you around 3 centimeters of absolute accuracy. And then we have one which is much more affordable in many ways, in some ways also easier to use, but that's going to be giving you about 5 centimeters. So a big difference there to consider too is cost. What is the size of your company? Are you able to calculate the return on investment easily based on previous experience with LiDAR? And again, what is your objective? Where do you intend to deploy the technology? And will it meet the requirements of that project? That is really a very good way to start approaching all the different options that are out there, not just at GreenValley, but across the entire marketplace, vendor side of the marketplace for these technologies.
Okay, fantastic. So that's a good level view. So one of the things I know that we look at as RMUS and our partners is, number one, is it easy? Is it easy to use? And does it make sense? Do we have to do all kinds of aircraft modifications? Is it a custom build? And this is anything but. So now I'm going to beam you live a couple of conference rooms over to our director of technology up here, Fraser Hahn, and Fraser is going to show you everything in real life and talk about a little bit how it goes together. Fraser, over to you, my friend.
Thank you, Kevin. So guys, I want to do just a quick overview of the hardware components of one of these systems and just tell you very basically how to put it together, set up, and then go and collect some awesome data. So what I have here is GreenValley's LiAir V70 scanner and DJI M300. And this configuration is going to be very common. This rig is really hitting a sweet spot of user experience, quality and accuracy, versatility, and the price point is pretty awesome. So this is the air unit, the scanner. It weighs a little over 2 pounds, and you can use it in pretty well any temperature conditions that you're likely to face in the field. It's workable down to -20 Celsius. And for those not using the metric system, that's very cold, but I couldn't tell you exactly what it is in Fahrenheit. The scanner is pretty much plug and play. It just goes right onto the DJI Skyport like so. We've also got the base station here and a base station antenna. Now this can be mounted on a tripod and placed over a known point for control. This base station is powered from a Mavic battery. So nice and simple, we all know how to use that. And then we have the antennas. And I've pre-installed these on the bracket just for ease of use here. They basically just mount on top of the aircraft. The bolt holes are already in place. Simple as that. And the antennas get plugged into the scanner. And then you probably want to secure these antenna cables to the landing gear leg with like a zip tie or something like that, just so they're not hanging up on the propellers. So the system is now pretty much ready to deploy. I just hold the power button down on the scanner, turn it on. Once it's initialized, I just press that button again, and I've created a new project folder. And then the folder structure is automatically generated and will be auto-populated by the files that result from our data collection here. So now we're pretty much ready to go and collect data. The scanner is able to start recording laser data once the aircraft reaches a certain altitude or when it reaches a certain speed, depending on how we set it up, just so that we're not collecting redundant or useless data. And then the same thing will happen when we're done the mission. The scanner will stop recording either when the aircraft has slowed down for a certain amount of time or when we drop below a certain flight altitude. And again, that depends on how we've decided to set this up. And as far as how we're going to plan a mission to collect our data, we can fly the aircraft manually. We can also use the mission planner built into the DJI Pilot app, which allows us to do grid missions, waypoint missions, etc. I'm sure many people are already familiar with that. We can also import waypoint or other missions in a KMZ format into the mission planner built into the DJI Pilot app. So that would give us more flexibility and perhaps precision as far as planning those missions. And then we also have the option of using any third-party mission planner apps that will work with the DJI system, including GreenValley's own Live Planner program. Once the mission's complete, we just transfer data from the base station, the scanner, and if we're using it, this optional and included camera here. This is a 24 megapixel camera, which can be used to colorize the point clouds. So once we've got the data on our laptop, field computer, or what have you, that goes into GreenValley's LiDAR georeference software for post-processing. And the result of that is, of course, our point cloud. So once we have our point cloud, that can go back into your existing workflow, or GreenValley's got lots of other tools that we can use to work on that data. Some are vertical specific, but I think overall they're offering pretty well any type of function we might need. So Liam, can I pass this back over to you, and you could tell us what cool and interesting things we can do with this data using some other solutions from GreenValley's software suite.
Hey, Fraser. Thanks for that great introduction to the hardware and a little bit about how to set it up and how it's actually operated. So as you pointed out, we have LiDAR georeference software. This is part of our operational software pack that comes with the LiDAR V70. And really, this has got all the tools that you need to take all of those raw data collected by the LiDAR V70 system, as well as the GNS or GPS base station you've been running, and even images from the camera if you have that, and correct that data, the GNSS data, fuse it with the IMU data, fuse it with the camera data, and actually produce your final point cloud. You can then take that and export it from the LiDAR georeference software as a .las file, a LAS file, which can be easily opened up in many different point cloud post-processing suites. Or you can bring them into a software we have called LiDAR 360. And I always like to think of this as the kind of Swiss Army knife of point cloud post-processing tools. A lot of different great functions in there that span anyway from data management to classification tools to even some more industry vertical specific tools for those working in the forest products industries, as well as in the mining industries, aggregate industries. And what I'm going to do now is actually show you what some of the outputs of the V70 look like within the context of actually application of the data that's collected in itself. So I'm going to share my screen now. Bear with me one moment. And I trust you can all see my screen right now. What we have here is the LiDAR V70. You see on the far right side is the actual camera. It's a Sony a5100. It's propped up on a little metal box that is actually the data recorder for the GVI base station. Connects to that antenna, the white antenna Fraser had set up on his desk. And then you see the GreenValley logo reflecting there in the actual cover of the Livox Avia sensor. That is where the LiDAR pulses will be emitted from and actually received back as well. So this is the integrated unit that GreenValley builds. It's on the black case that arrives in. It's nice and easy to carry between job sites. You can put it in the overhead compartment of a plane. So it's in that sense, it's also kind of a revolutionary product. Is you used to have to go to any UAV LiDAR job a small van with you, and now you can basically just with two hands get around from job to job. So it's quite nice in that sense. But what do you actually get? Well, you get accurate 3D measurements. So we talked about accuracy earlier. One of the ways that you can actually improve the accuracy and assess it is to put out checkerboards, similar to working with photogrammetry. You see in the top there, this black and white image is actually an intensity view. And this is basically the reflectance values of the laser pulses. They hit the target and then return. And viewing it in this way, you're actually able to see where your centers of your checkerboard targets are. So if you can imagine, if you overlaid ground control points here, you can do some point picking and figure out what your different vertical and horizontal accuracies are. That's one of the really nice things about LiDAR data, is also having this intensity data. It allows you to filter out certain feature types, and it's just another dimension of information on top of the XYZ coordinate values that come along with each point. And then in LiDAR georeference, if images are available, you can colorize your point cloud. So really, this is a type of data fusion, right? You're taking red, green, blue band values, and you are fusing them to the XYZ records of the 3D point cloud measurement. So in this example here, you see we have a parking lot, marina. You can now ask questions not only how many cars in the parking lot, but what are the colors of those cars, what are the distributions of colors. So that might be a kind of a silly example, but a more serious example of that is something like forest management, forest health management, right? Where you have these trees, they all have a similar structure in terms of their 3D shapes. But when you fuse that color value into the data set, you get this extra level of information. And here you see there's been a beetle outbreak, and you're actually able to pick out pockets of beetle kill or fungi or disease that are actually taking place in a forest setting, maybe when they're small, and you can actually apply a treatment to it to hopefully contain an outbreak. But this is in a situation where having that spectral information, that RGB information fused with that 3D LiDAR data can be incredibly informative, and it really makes for a much more useful data product. So here's another example of a forest LiDAR data set captured from our LiDAR V. And what you have here is just a 3D point cloud kind of displayed by this height values. And a lot of times what the good thing about LiDAR is, and really where it's superior to photogrammetry, is you're able to see through the vegetation. So this is after I've classified what we call ground points. It basically only view those here in 3D. And you're able to see actually what the terrain looks like beneath the tree. So this is incredibly important for if you're doing any sort of bare earth modeling, hydrological studies. This actually was a site that had previously burned. And one of the things you can do here is do some prioritization of your erosion control measures that you might take post-burn. You can also see here there's forest logging roads, skid roads that have been kind of hidden by the vegetation. So if this is a piece of forest land that you're managing, you'll be able to kind of use this technology to see where your road networks are. And this is incredibly useful for a natural resource manager. And then you can take these point clouds, right? And you can basically turn them into raster surface, continuous surfaces. And these would be called elevation models, right? So these could be DEMs, DSMs, if you have the trees and surface features still on them, digital surface models, that stand for. You can also calculate things like aspect maps, roughness maps. A lot of these are classic kind of elevation data products that geospatial users may be used to, but all these can be created in our LiDAR 360 software. Again, that software I said, something like the Swiss Army knife of tools. It allows you to do all that classification work and then actually produce these raster elevation models. And here you can actually visualize them in 3D through something called our live model. And then you can also convert them into things like contour lines, right? And these contour lines can be exported as DXF files and brought into CAD, again, for if you're doing some road planning type work, road engineering work. Or you can simply export them out as maybe a shape file and bring them into programs like Google Earth. Here you see it overlaid on it as a 3D kind of view. And this can be incredibly useful because now you can hand this to a person who doesn't have LiDAR 360 or any background in LiDAR, and they're immediately able to leverage the information in the data in a pretty easy to use way. So I talked a lot about forestry and natural resource management. We have great tools in our software suite that really target this vertical. But you see here, these are all screenshots taken on the on the right side of vertical profiles from different forest types, right? So depending on your forest type and basically the density of the canopy structure, this kind of affects what your penetration is and thus your ground point density. So there's different operational things you have to do in different forest types. Maybe you fly tighter spacings or come out from different angles to increase canopy penetration. But this is definitely where, as an operator in the field and how you do your flight planning layouts, you can really improve the results in some way. So this is a very in-depth topic, and it really does warrant an entire webinar maybe in and of itself, is this discussion of how to in-field best practices for data collection affect the quality of the downstream data products generated from what is collected. One of the other big areas of use that we see is in volumetric measurements, right? So one of the benefits of LiDAR data is that it's 3D measurement to begin with. So you're taking volumetric measurements, which are 3D measurements from 3D data. And this is kind of contrast to photogrammetry, where you're taking 2D data types, images, and then taking and turning them into 3D data structures, and then actually taking your volumetric measurements. So there's some time differential there. It's a lot longer to get to your volume measurements if you're just using photogrammetry than using something like LiDAR. So in this site where we have trucks coming in, dropping off this sort of sand here where they're building up a housing pad, in real time we can see what each load is contributing to the overall stockpile here that we're building. So this is just one use. It's actually, we see quite a bit of adoption of this, even though it can be done with photogrammetry. It's much quicker with LiDAR. And then along those lines, you can do change detection. So there's, in this situation, there was a landslide. It's going to show you here the before and afters, and you can see they're kind of heat mapped to show red where the most accumulation and depositions occurred. And then you can actually estimate the volume of material that's been moved. This analysis is carried out in our LiDAR 360 software in the terrain module. So again, this is a great tool for people, and it doesn't have to just be for something like landslide detection. You can also think about it. We can go back to our parking lot example. You can scan it time step 1 and then time step 2, compare the two, and quickly see where cars have come and gone. That's maybe one example. Or even in a forest, you want to see where trees have grown in or disappeared across time. So some sort of forest change monitoring type tool is something you can do here as well with the LiDAR data and the tools found in LiDAR 360. Again, mining is a place where LiDAR is really finding a foothold, not only just in the volumetric side, but also in the tunnel sections. So this is a little harder to achieve, obviously, with UAV LiDAR because you're GNSS denied when you're below ground, and LiDAR V systems all require GNSS coverage to operate. But we have the tools in LiDAR 360 if you do have terrestrial LiDAR data, subsurface data to actually do section analysis. So this is really where GreenValley does offer kind of this end-to-end. We get you all the way from raw data collection to processing that raw data to these kind of post-processing tools that help you deliver analysis, right, to the end customer. And that's usually what the objective is of any data collection project, is to derive something from the point cloud and not necessarily just deliver the point cloud itself. And a place where analysis of point cloud data and LiDAR data is really also taking off is in the inspection of Powerline corridors and towers themselves. We make a software called Powerline that really targets users just in this space. And what this is able to do is use some deep learning tools to figure out what's a conductor, what's a tower, what's the actual infrastructure asset itself, and then what are these surroundings. And then users can specify what their tolerances are for clearance, and then we can automatically detect where these clashes are, or there's potentially danger points showing up, export those out in really user-friendly reports that can be handed off to a tree trimming crew or vegetation manager at a utility. So it's a very, very useful tool, really targets this Powerline inspection vegetation management use case. So all these things I show you, there's varying levels of expertise needed to clean the data, prep the data, produce the deliverables. And GreenValley International, we have been around, as you saw Leo's slide earlier, since 2012, and we have a lot of experience not only developing these products but using them in service projects. And what we've really decided is, although all these are standalone software you can purchase with perpetual license, so you can process your data in the field, you don't need an internet connection. Many people also want the ability to outsource some of that data processing to produce these deliverables, and that's where we have a cloud-based data processing services. So to find out more about these services and any of the software, the hardware, RMUS is a great source, or you can visit greenvalleyintl.com to find out more. And of course, reach out to us at info@greenvalleyintl, or get in touch with RMUS, and they will put us in touch as well. So with that, I'm going to stop sharing my screen, and and hop back into our webinar here. And that's all I have for some of these downstream stuff.
Perfect. Liam, I mean, highly impressive. I mean, there's so many questions, like I said, about LiDAR in general, so many specifics that come into play on accuracy and data and showing us exactly what is capable as far as what you do with data after the fact. But just a couple of questions for Liam, and then I've got one for Leo. But basically, from one of our viewers, they have a question about the base station. And this is a valid question because the base station itself, there's a lot of already land surveyors and whatnot that have their own base stations. And just to understand the ecosystem of the GreenValley setup here, is that a requirement that they have to own your base station? Can they connect to other base stations? How does that ecosystem kind of work? Because I know there's a lot of investment into these systems that are already currently out there. Now they're trying to buy the drone, buy a sensor that can communicate. Can they use their own base station is basically the question.
Excellent. Yeah, that's a great question because it really does identify the fact that a base
station. His audio again?
I believe you muted your mic. I think.
Can you hear me now?
Again. Almost.
No.
I'm still don't have him.
Can you hear me now?
Yeah. Anyway, if we're trying to do that, let's just see if we can get Liam back on here. But yeah, that's the question, Liam. As soon as we get that fixed, whatever it might be, is can you use it at the base station? Then I have a second question. As soon as we get this going, is the amount of data that or not data, but basically the amount of time it takes to create these deliverables. I've definitely watched how the collection of the data has been simple and easy, but it isn't always easy to then do what you had just showed. You have the cloud-based offerings of post-processing, but what do you think is basically in a training perspective? Do you guys do any training or anything like that as far as the training goes? So one more two-part question. Can it be used with another base station? Do you have any level of training?
We've got it back. I'm pretty sure we've got it back. Yep.
Okay, I know we had some audio issues there, so I think we're going to have them resolved now. And I'm happy to answer this two-part question. It's actually a great question because it does, the first part about the base station, because it really does lock into key ideas that base station data is required, right? There's a differential correction of the GNS GPS data that's captured by the two little black antennas you saw Fraser mount to the device. So this is all done in our LiDAR reference software. We actually have a module called LiDNav. So the inputs of that are going to be the raw GNSS observations that are taken by the onboard antennas attached to the top of the drone, and then the base station file, right? So that base station file can either come from the GreenValley International base station or from a third-party system. It just has to be brought in as a RMUS file, and you have to get the .n, the navigation, and then the observation file. So to answer that question very briefly, yes, third-party GNSS base stations can be used. And that is kind of a critical part of the post-processing. You really won't be able to get that 5 centimeter accuracy without that. And another key part to make it repeatable and hit those accuracies is to know the exact spot where that base station is set up. So with the GreenValley system, you'd actually have to set up of a known location, whereas with a third party, you could actually set it up, let it cook, and something like here in the US, we have Opus. You can push that RMUS through it, figure out a precise base station setup location, and then use that same RMUS file to differentially correct the rover data. So this is kind of confusing, and this is why training is actually highly recommended and provided by GreenValley via its through its partner networks, and also can be purchased directly through us in some situations. COVID's kind of changed it. We used to really be able to go out on site with people and show them how everything sets up and spend the day with them. But we have some virtual training options available now that we've developed over the course of the past year. But for customers interested more in that, please have them reach out to us directly or to RMUS, and we can get them everything they need in terms of the training to get up and running.
Okay. All right, so that was a question from Philip. Yes, Philip, thank you, because it is a very crucial question on understanding if we can use other data outside of what some of these manufacturers offer. In some cases, like specifically the L1 is usually using data from the drone. I also find this to be a little bit more crucial in the, as you say, absolute error that can happen going on with drone data, different RTK data, IMU data, sensor data. I mean, it just builds on more inaccuracies when you do that. So, but that's a really good explanation. And as well with the training, I hope that some people understand that it's complicated. I mean, just LiDAR in general can be very complicated. There's a lot of processes, a lot of steps, and not just buying the hardware is the number one thing, if we've learned anything from Liam today. I do have a question for Leo, more on an upper level space, but basically, Leo, the question would be coming in is, what other, and I didn't imply, hopefully I didn't poke you too bad in the eye in saying that you guys were the new kids on the block. Obviously, you guys have a huge foundation of LiDAR data and understanding, but that's kind of what I'm segueing into. As far as the company goes, what other type of systems do you have out there besides the drone stuff? I mean, we see a lot of data out there, we see a lot of stuff, but in GreenValley, just looking through the website, looking at some of your stuff, where are the industries that you've probably been the most impactful as far as GreenValley LiDAR experience over time?
All right, thank you, John. That was an excellent question, and no problem at all. And GreenValley was relatively less known compared to some of the other incumbents in the industry because we haven't been too aggressive pushing to other markets so far, but we just started launching major campaigns since last year. Now, to your question, GreenValley has a full portfolio of LiDAR-based solutions, from the aerial systems based on larger airframes like helicopter, fixed wing, to UAV LiDAR-based systems like the LiDAR V70 we just looked at, and to auto-based Light Mobile system, and the Light Backpack, which is for you to carry on your back and to walk. And it's a classic SLAM-based solution. And on the software side, we have the LiDAR 360, and we also have Light Powerline, as Liam just showed everybody. And to the question of where we have been really making impact. Now, that's a really interesting question. But first, I really want to say is there's something that can really differentiate GreenValley from other providers in the industry. GreenValley is very heavy on R&D. Our headcount is approaching 200 to date, if not already over 200, and we have a very large R&D team, software engineers, hardware engineers. So we are much more capable of iterating our products and our technology very quickly according to what we see from the marketplace and the demands from our customers. And also, as I mentioned a little bit a while ago, that we have a large actual service branch. We do a lot of service projects. And now this goes back to the question, which industry we have the most impact? Well, we so far, we are mostly focused on three industries: mapping and survey, Powerline, and forestry. And forestry is where we started. I think it's probably fair to say that the GreenValley still holds a lead in terms of providing LiDAR-based solutions for forest management. Our very first product, funny thing, is what's called a Live Forest. If you Google it, you probably can still find the residual website and some remnants out there on the web. It's a piece of software. So that's where we started. I think in terms of the fundamental technology utilizing LiDAR for forestry, GreenValley probably still holds a lead. And our founder, Dr. Michael Gore, is still one of the leading scientists actually in quantitative forest ecology research in the world today. But that said, I would say the industry we're really focused on the last 2-3 years is Powerline, as specifically is vegetation management for Powerline. So that would be an area GreenValley has not only a lot of the products that the customers may need, but also a lot of experience. And that in turn helps that experience coming from providing and conducting those service projects really come back to help us to continue to improve our products and the fundamental technologies to support those products. So that would be where I think we will continue to make most impact for this technology.
And I think overall, like I said, just understanding like coming into the UAV, because I do pay attention a ton in the UAV space as well as that industry, and again, just not hearing so much about GreenValley themselves, it's really great to see that you guys have so much experience and so much time of understanding. This makes it awesome for any level of support, and that's the next question. So I'm gonna come to Fraser here in just a second, but as far as supporting the customers, helping our customers, I know that we always have a huge challenge with that when we have something fairly new. Bastian is one of our viewers here as well. He basically is just asking about some demo acquisition to the clients to assist them in choice of LiDAR. So RMUS does have a slew of different products that could qualify, GreenValley being one of them, for whatever you guys need, whatever you need to make a choice on what system to buy, integrations, what ships you have, and I want to say that there are some systems that are only going to work on specific machines or specific setups, but that's the Fraser question. We did see, Fraser, that you were putting on basically the system onto an M300. It has the Skyport lock and everything else. As an end user or as a user right now, have you tried it on anything else? I mean, it looks like it's a completely independent system. We don't need to actually have it flying on an M300. Is it possible to put it on other things so that, again, we can open that door of versatility just a little bit, more so than just being stuck on a DJI or a specific product? So over to Fraser on that question.
Yeah, thanks, John. Great question. So the LiAir V70 in particular and the LiAir series at large is plug and play with Matrice systems in the sense that they can plug into the Skyport for power supply. And that goes for the M300, the M200 series, and the M600. Now, some of the larger, heavier scanners can only currently be deployed on like an M600, for example. But these payloads are not tied to DJI systems necessarily. As long as they have a power supply, they can be flown on anything.
Perfect. So there is no limitation, obviously, with that. And have you, as far as now moving data from one spot to the next spot, being out in the field, you've had a little bit of experience with this. And I don't want to necessarily beat anybody up on this question, Fraser, but what is your end user experience here? Just kind of understanding as a data collection. We already know that it takes some time to really do a good job doing post-processing to create all of those awesome things that Liam was showing. But you know, as far as I just get out there to the field, I flight plan, I'm ready to go, I've got data, I export it out. What is that looking like for you as far as your experience so far?
So from what I can see so far, it's my impression is that it's not at all intimidating. Like Liam said, the software tools are extremely detailed and flexible. That's a pretty deep rabbit hole if you want to go there. But from a data collection point of view, this is accessible to everybody, and that's what we need, of course, because small UAS solutions are being more widely adopted, and they need to be accessible to pretty well anyone who wants to be able to use them. That's definitely the case here. The sort of very basic workflow that I talked about earlier, that's pretty much it as far as data collection. Like, there's a few minor steps that I glossed over, like maybe you have to wait a little longer for initialization, and this is the sequence of lights you need to see. But the basic steps that I described, that's about it.
When it comes into, because Philip asked another great question, using the power supply from the M300 plus it being flying on the bottom of this, 2 pounds I think is what you guys were saying is how much the unit weighs, but if we are putting it on a little bit not power pulling from the drone system, we'd have to then add an external battery. So in doing so, it's possible that we might diminish flight time or anything like that. So just for a little bit more detail, Philip, though, since you'd asked the question, I'll try to get, if you already know, Fraser, what are the power requirements for basically riding alone on something else? Additionally, besides being on a drone, do you think, can we put it on anything else? Does it help at all? That might be a Liam question, but can you just stick it on a car? Can you put it on a vehicle? Is there any reason to do that? Walk it around a building? Is that capable? Is it not capable? So first question, power, does it affect your flight time on the M300 right now?
So yeah, it does affect the flight time. I couldn't give you specifics on that. The power consumption I don't think is huge next to the systems that are already running on F300. The mass at like a little over a kilo, a little over 2 pounds, that's significant. But the M300 with an excellent battery life as it has should not be too limiting. And as far as powering this with other systems, I don't know specifics on this. I'd have to ask Liam, but the voltage inputs that it will accept are pretty wide. So if you're running this on like maybe a Watts Innovation system or some other multi-rotor, the power system on that aircraft should be able to feed power to the scanner. I don't think an external battery in addition to the flight batteries would be required in most cases. But let's pass this back to Liam. Can you tell us a little bit more about that?
Yeah, certainly. I would be happy to. We are trying to be platform agnostic. The Skyport is great because it can pull power directly from the Tree series. But we have the ability to be compatible with things like the Watts Innovation. It does require a little bit development if we haven't deployed it on the system before in terms of the power source. But you'll see on the front panel, on the Liar V70, there's a LEMO port to pull power directly. And at the end of that cable accessory we can sell has an XT30 power connection. And the ideal power source is going to be pushing about 14 volts. So one of the batteries that's pretty good for this is the Mavic 2, and we can have kind of an XT30 to Mavic 2 power connector accessory built for you. But one of the things to really keep in mind too is when you're integrating other systems is it's not just about the power, but that lever arm offset between those antennas that you have to mount on the top side of the device and make sure there's no interference to the actual coordinate center of the payload itself. So this again is something that requires a little bit of customization, but our technical support team can walk through that. Just when you are at the purchasing point, speak with your sales rep, do make that known so that we can get ahead of it and just get everything lined out that needs to be done.
Great addition to be able to run, and I will make this ad on other developers that have created external power systems, as Liam has explained. Using a standard lithium polymer battery has always been very complicated for some people to manage that. So using the Mavic batteries are really smart. I really like that. Kind of a specialized thing I've only seen actually GreenValley do. So it's actually a pretty neat thing. Also, it looks like we're using that same type of that proprietary connection for the ground station, which is also makes it so much simpler on basically our end users that don't have to manage the lithium polymer cells, worry about whether they're doing stuff. I mean, having a smart battery running everything is really, really smart on your guys' end. Pretty neat to see. Lastly, Liam, and again, just maybe a little bit more, because we don't have a whole lot of data sets that are available. Do you guys have, I mean, I've seen that you guys have some data sets that are available or for post-analyzation for any customers that might ask, but I think you guys house these on your website. Another one for Bastian's question is just, when we're trying to analyze and purchase and buy something, it's always helpful to have some kind of information that we can take from the sensor itself, maybe a little raw data or whatever, get it over to analyzation so that we can decide, what is that accuracy, how well did it work. But do you guys have data to share via the website as far as uploading and getting that?
Yes, absolutely, we do. Maybe I can share my screen here real quickly and go to our website, and I'll show you exactly where this can be found. I will share my screen. So this is the GreenValley International website. Underneath the resources section, you'll see something here that says sample data. This is going to actually have sample data from all of our products, not just the LiDAR V70. So we haven't talked about it today, but we have SLAM-based mobile systems from our Live Backpack line. But what we're really looking for is this V70. We have some infrastructure, some buildings, some Powerline data here, as well as data sets from all of our other systems. But these are nice snippets to kind of analyze. You will notice that the data formats are LiDATA. So LiDATA is a file format that GreenValley has developed. It's spatially indexed and really designed to work on our GPU-enabled software. So you'll be able to open these up by going to the software download section and downloading the 15-day trial of the GreenValley software suite, which will give you all of LiDAR 360 and all of the functions found in it. You'll be able to open up the LiDATA file in there. If you don't want to spend time exploring LiDAR 360 because you really want to analyze how it works in your software, at that point you can export it out as an LAS file or an ASCII file or E57 file or whatever point cloud file we support. And that's kind of how you can get a look at the data yourself. So I hope that answers your question.
Yeah, perfect. It's definitely so helpful when it comes down to customers asking these questions. We don't always have, every piece of data that people want or for that analyzation. So having that resource is excellent. I think, Kevin, I don't know. I don't really have a lot more questions here. I guess the only other one I had, Liam, is maybe just some there's a lot of people that want to use it besides flying up in the air. That is a pretty relative question for people to put it on other things. Do you have anything that you can talk about there? If it's just not capable, that's fine too. But where are the limitations on that, or what could be a bonus on that?
So that's a great question. We do get it all the time. So the LiDAR systems really are not designed to be mounted to a car. And one of the reasons why is that they are GNSS is required to actually build out that trajectory data that then the laser scan measurements are laid out across to produce your final point cloud. So if you go into some sort of float with your GNSS fix, or you just have super low quality, low satellite counts because of buildings and trees and multipath effects and blockage that can occur because of those environments, like you would find on a road, you're going to have blackouts in your GNSS data, and it's probably going to make a result that's not very good relative to what you're going to see if it's mounted to a UAV, where you're up above the trees, above the buildings. Multipath signal is not such an influence. You're just mostly worried about satellite coverage, but in general, that's better the higher up you are because you see more of the sky, more of the horizon. So we do have customers who ask this, and really we just say we do not test it on mobile, on cars and roads, and it's really designed to be in areas where there is really good GNSS coverage, like above trees, above buildings, in the air. It's an aerial platform.
Yeah. Perfect. So how about merging data? Even though you've got some, you're doing mostly the aerial stuff, which is definitely a huge proponent into that. But how about marrying some of the ground-based data? Any of the other systems that you have that might be able to solve that? As far as just marrying these two things. And like I said, I've learned that LiDAR data, messing with it, changing it, manipulating it, and kind of making it whatever deliverable you want, takes a bit of training. It takes a little bit of understanding, and for those that really know their way around it, great. But we have so many people that do not. So merging data basically is the question. Can you move this data within other pieces of equipment that have collected stuff as well?
Yeah, data fusion would involve fusing different types of data like imagery to point cloud vector data, but fusing multiple point clouds, right, collecting from different laser scanning systems, some being aerial, maybe some is a terrestrial, maybe another is a mobile ground-based system. This is really why absolute accuracy is important, because if the accuracy of each of those separate data sets is comparable, 5 centimeters, or as accurate can be in real-world coordinates, when you overlay them in 3D space, or basically plot them in the same 3D space, you'll see good alignment between the two data sets before you even write them to the same database. So this is where absolute accuracy is really important when you're going to be merging point clouds collecting from two systems to maybe get your interior building and exteriors covered in the same point cloud, or you have an above ground portion of a mine site and a below ground, and you need the two to be in one large point cloud for analysis. The absolute accuracy is going to be where this ties in. So we've got our system to be 5 centimeters. The other system you should compare it with, infuse it with, that would also have to have a similar level of absolute accuracy. The other thing you can do is basically use some tools in LiDAR 360. There's an iterative closest point algorithm that will basically, once you get them close, find matching features and try to tighten up the fit. So this can be helpful when you're trying to align data sets. But merge is really an operation which you can do in LiDAR 360, where once you have everything aligned and you want to export it out as one LAS file, one light data file, we can do that in our software as well. But yeah, it really comes down to the inherent absolute accuracy of each of the 2 point clouds, and how good that is will somewhat dictate how good the alignment is between data sets, and then you can merge them when it's satisfactory.
Perfect. Well, I would dare say that this has been a very fantastic webinar. We've actually pushed our time just a little bit, but great content. I will say there's been a lot of, you guys are just fantastic as far as information. Kevin, I was just going to jump back to you if you had anything else to add as a co-host here, and as well just maybe take us to a closeout, and just anything else. We just thank you for the guests. Kevin?
Fantastic. Thank you, John. And thank you, Leo. Thank you, Liam. Thank you, Fraser. Great webinar. So we'll have plenty more content. I know LiDAR is an area of interest, so we'll get in depth into some of the areas Liam talked about. Look for us on our learning portal to have some more aerial LiDAR specific modules as well in the next little while. So happy 2021 to John and Jace back at HQ. And thank you, everybody, for joining us. And we'll see you next month with some other new and fun stuff. Take care of yourselves, everybody.